catch up to you guys a little bit.
So this, you'll realize that when the claim is they're the same or they're different, it's not as important which one's 1 and 2. But you know, just start getting used to really being careful about which one's population 1, which one's population 2. So these guys showed up first, we'll call them 1, call these guys 2. Claim is that the population means are the same. So that definitely goes in for the null.
No, we didn't want to use symbols in the claim section.
Of course we do, yeah. That's the point. No numbers are going to show up.
Under the numbers.
Yeah. Because we don't have some set number to compare something to. We have a comparison of two things we don't know either one of them. It feels more like real life. 1 or 2 tail test. 2 tail. Yeah. Oh, I'm being so nice here. Can we use z-scores? Yes. Why? Because then I added the statement normally enough. And what else? Yeah, sigmas, they come in apostrophe. Sigma's known. So therefore, you can use z-scores. Yes. Okay. Rejection reagent, 2 tails, 0.05 level of significance. What's it come out to be? Yeah, 1.96. Holy shit. This guy got it. Excited. So if z star is less than negative 196 or greater than 196, we can reject this guy, support the other guy. We make it into the rejection region and we can reject. You know, it's crazy.
So it means 5% on either side, not 2.5% on either side.
No, it means 2.5% on each side.
2.5%.
Yes. So if you look at 0.05 in 2 tails or 0.025 in 1 tail, you end up in the same column either way. I like it. I like it. I remember the 5% 2-tail dude is exactly how we defined unusual before. That's why the z-score is almost exactly 2. Because we said 2 was unusual because 5% was outside of there. That's why we said that sounds like a good unusual thing. And it really is totally just, yeah, that sounds about right. That really is what it was. That's how we defined it. Isn't that great? I love statistics. It feels good. So what do you guys get for X bar 1, the mean for the females? 80.46, all right. And then I told you this guy, 11.09, and we had how many women? 14. Is everybody cool with that? Okay. So he's like, yeah, that's fine, just keep going. All right, what about for the men? How'd they do? 76.29? And I told you their spread was 12.33, and there were how many of them? 12. And we were completely cool with there being not equal sample sizes. I like it. There are certain tests where the sample sizes have to be the same, but one example of them would be weigh some people before they start a weight loss program, weigh those same people after. You better have the same sample size, or else did somebody like diet themselves out of existence? I don't think so. All right, so anyway, that obviously is a situation where the sample sizes have to be the same. Here, it doesn't matter. So then now I take the difference, 80.46 minus 76.29, divided by this big ass representation for the spread. And the most common mistake is to forget to square these poor little sigmas. or to square the ends also, either under square or over square. Don't do any of that. So, how'd I come out of there? That sucks. See, now this is perfect. You see how I can see I came out of that square root for some reason? Okay. Delete. Oh shit, I went too crazy. Delete. I should probably start over. Okay, let me go back in. I'm in. 14. What do I do? I don't really want to. 12.33 squared divided by 12. I like that that happens, so you see that. I don't care how good you get at math, you can make stupid mistakes all the time. Hopefully you don't take that to be, like, defeatist. So this is 0.9. Just by itself. And what is that again? It's physically, what is that? 0.9 is a z-score. So right there, I mean, what does that tell you? Is that very far apart? It's not even a full step apart. That's shit. Right? Now, on the surface of it, if you look, see, again, this is why we do the test. Because you would say 80 and 76, they're very far apart, but they're not very big samples. The spreads were kind of big. So that difference really didn't end up being very significant. It's only 0.9. Who cares about that? So right there, I failed. I didn't make it anywhere near. So there's my star right there. Fail to reject. The null, fail to support the high. Well, if we really feel like this is true, we could continue and get larger sample sizes, and maybe then it would become significant difference. Or maybe then the difference would evaporate. We don't know. Real quick, did somebody find the p-value for me? What? Oh, almost. It's a two-tail test. So whatever area you get, you better. If it's a two-tail test, you get that number and then you double it. 3682 or like. And in terms of PETA, that's crazy big. That's like, what the shit? That's nothing. Good Lord. But like you said, like somebody's just brought up, kind of small sample sizes. If we really feel there really is a difference, I'm just going to go take some more samples. I'm going to try to increase my sample size. It could be this small and this insignificant just because the samples were too small. Maybe. What was the other thing I want to say? Oh, I want to show you that. What's my conclusion? We have not found sufficient evidence to what my claim was my HO. So I want to use this language right here. Fail translates into we have not found sufficient evidence to reject the claim. That male and female averages are the same. So again, the samples were, by just looking at them, they looked pretty different, but they weren't different enough to say that the populations were different. Could the populations be different? All day long. Could they be the same? All day long. We don't have a clue. Oh, I want to show you something. Just so you see this, I mean, you definitely don't have to know how to do this, but just to show you what this little expensive thing is capable of. If you go to stat, do you see here where it says tests? I don't know if anybody was ever curious about that, because what are we doing right now? We're doing hypothesis tests. And look at all this shit, look at all this shit. Which one did we just do? 2 sample Z test. Now look what it asks you if you go here. If you go stats, make sure stats is shown, because then I can just plug all this stuff in. Let's see what it does with this. I'll get down there. Sigma 1 was 11.09. I'm just going to plug all this stuff in. Sigma 2 for the men was this. The women's mean was 80.46. The women number was 14. The man was... Okay, Jeff, shut up. And there's 12 men. It was... This is always going to want to know what you're testing. What are you trying to show evidence for? We're trying to show evidence that they're not equal. So we're going to pick this option, not equal to. The color is because you can actually draw the situation out. But I just wanted, let's see what we get for the calculations. Let's see how close. Look. Do you see anything? It looks at all familiar. Something is a little bit different because we use a chart that rounds stuff. But look, 0.9. We got Z of 0.9. We got p-value we got was 0.3682. I'd say that's pretty damn close for using a chart that's rounded to 2 places. Right? And then you just summarize the other shit that we already knew. So that's kind of nice to know how to check your work. I don't want this magically showing up. That's always a bad sign. If you don't want to do this at all, don't. That's fantastic too. I don't care. Maybe. Yes? Yeah, so go to stat, tests. The first 2 would be chapter 9. And then the next 2 are chapter 10, because chapter 10 is all about 2 samples. And then, and then number 5 would be from chapter 9 for the test for proportion. And number 6 would be from chapter 10, section 10.3, the proportion, 2-sample proportion test. And then look, there's intervals. Oh shit, there's confidence intervals in there? Oh, Jeff, you're so mean. And there's look at all this. We're going to learn this. We're going to learn C. Do we even know how to say that? It's not X. It's a Greek letter. It's not from Dragon Ball. It's called a chi. And then anyway, sorry. So all that stuff is statistical tests that you learn in Stats 1 or Stats 2. Any questions from this problem here? So I could have done more out of chapter 10, but to find out we're doing pretty good on time. I got as far as I wanted to today, so. You guys want to do more than 10, right? You want to do... You're like, I don't want to say no, but no. That's plenty, guys. Everybody's got a practice test, right? So I'll have the answers on Monday. The test is next Wednesday.
What would it take to be able to confirm your hypothesis on this problem? What would it take to confirm your hypothesis on this problem?
To confirm that they're equal, it would take knowing the entire population. The only way to confirm equality between 2 populations is to actually have the entire population set of data. Huh? Oh, well, there you go. So confirm kind of implies 100% certainty. Yeah, but yeah, you could. We failed to reject. So this is like tentative confirmation that they're equal because we haven't shown they're not equal yet, right? So every time somebody tries to disprove evolution and they fail, that's sort of like more evidence that it's true, but we can never prove it's true. I like it.
think the odds to be like astronomically small if they're equal because
Yes.
that's why I said a bigger.
Yes. So your real question is, equal kind of doesn't mean equal out to the 80 billionth place. There is kind of like what's called a neighborhood around which we accept to mean it's equal. You see what I mean? Yeah. So that's kind of like what you thought about. Probably. Maybe. This. So I think we finished that. Oh, was that? That's when we did the whole test for ESP. Okay. So that took up a big part of the class. Test for ESP.
Here, right?
6:30 is my office hours. Yeah. But I am there earlier.